Welcome to today's Explainer. We are jumping right into a massive, frankly urgent mystery in the tech world right now. You know, we've all been sold this idea that if you just give people access to generative AI, whether that's at work or in school, boom, instant productivity, skyrocketing results. But what if I told you that simply using AI doesn't guarantee better outcomes at all? In fact, without a very specific set of mental skills, it's basically just an illusion. So today, we're going to unpack exactly why this happens, and more importantly, how we can actually fix it.
Okay, let's kick things off with a massive scientific study involving nearly 4,500 students. Now, the baseline assumption going into this was pretty straightforward, right? Students who use AI tools more intensely are naturally going to see their grades go up. It totally makes sense. You give them a super smart digital tutor, and their performance should skyrocket. But when the data came back, the results were actually shocking. The study found a definitive statistical null effect. Yep, zero direct impact on academic performance just from using AI. Crazy, right?
What's truly wild about this finding is the methodology the researchers used. They didn't just casually count how many times someone opened a chatbot. No, they used a highly sophisticated machine learning approach called CatBoost to create a custom weighting system. Basically, they measured the absolute intensity of AI usage, meaning the variety of tools used and exactly how they were applied in different educational contexts. But even with this hyper-accurate, individualized measurement, the conclusion stood absolutely firm. Intense, varied engagement with AI did not improve grades. It's a phenomenon we're calling the AI usage illusion. It proves, beyond a shadow of a doubt, that mere exposure to artificial intelligence just isn't enough.
So, to solve this paradox, here is our rapid-fire roadmap for this explainer. 1. The AI usage illusion. 2. The evaluator's disconnect. 3. Why fluency bypasses heuristics. 4. The AI Evaluator Threshold. And 5. Designing explicit verification. Let's get into it.
Section 2. The evaluator's disconnect. Let's look at why our brains are fundamentally failing us in this new landscape.
The big takeaway here is that our mental models for evaluating information are, well, they're dangerously outdated. Think about it. Traditional critical thinking was built for human-to-human interaction. It relies on transparent arguments, verifiable evidence, explicit premises. If you read an essay written by a person, you can trace their logic step by step. But generative AI systems, they are entirely different beasts. They're opaque, probabilistic models. They don't actually hold beliefs or construct arguments, they just predict the next most likely word based on a massive hidden ocean of training data. Their reasoning is basically non-explanatory. So when we try to take our trusty old-school critical thinking tools and apply them to AI, our brains essentially short-circuit. The tools just don't fit the task. Section 3. Why fluency bypasses heuristics. So, if traditional reasoning is failing us, what exactly is tricking our brains when we read AI outputs?
Well, the answer lies in something called heuristic processing. This is a fast, intuitive cognitive state. Look, our brains are lazy by design, right? We always want to save energy. So we rely on simple cues, like a super authoritative tone or how smoothly a sentence flows, to decide if we should trust something, completely bypassing the hard work of deep analysis. Generative AI basically acts like a brilliant fluency mask. Because these models spit out incredibly eloquent, grammatically flawless, confident-sounding language, our brains interpret that smooth fluency as a cue for truth. It immediately triggers that fast, automatic processing. The AI sounds so incredibly smart and certain that it convinces us to drop our guard and skip the slow, effortful thinking we actually need to be doing. And this perfectly highlights the danger of that fluency mask. It leads directly to a phenomenon called automation bias. When we constantly chat with these highly articulate systems, we just start deferring to them way too easily. We take their outputs at face value. And it gets worse. Research actually shows that users experiencing automation bias will systematically favor the AI's answer even when it totally contradicts valid factual information from non-automated human sources. We literally abandon independent verification because the machine just sounds way too perfectly confident to be wrong. Moving on to Section 4, the AI Evaluator Threshold. To combat this bias, researchers validated a brand new 13-item framework to help us maintain actual human oversight. This builds into what we call the AI Evaluator Threshold. To safely navigate these tools, you need 3 explicit things firing at once. 1. Reflective judgment. 2. Verification. And 3. Epistemic motivation. Let's break these down. Step 1 is reflective judgment.
Now, this isn't just asking, hey, is this factually true? It demands that you actually hit pause and consider the broader context. Someone with high reflective judgment is actively weighing the structural limitations and the real-world downstream consequences of relying on that specific AI output. They're asking things like, how is this conclusion actually reached, and what happens to our whole decision-making pipeline if this underlying logic turns out to be flawed? It's all about taking a macroscopic view instead of blindly accepting the machine's word as gospel.
Step 2 is verification, and this is where the rubber really meets the road. Verification is the active, habitual behavior of breaking that fluency spell we talked about earlier. It means you don't just read the output and nod along. No, you open a new tab, you cross-reference external sources, you talk to actual domain experts, you actively hunt for evidence to disprove the AI's claims. For people who actually succeed with AI, verification isn't a chore, it's just an automatic reflex built right into every single interaction.
Finally, we have step 3, epistemic motivation, which, I know, is a fancy academic term, but it's actually a super simple concept. It's just intellectual curiosity about the machine itself. It's the willingness to put in the mental effort to understand how these generative models are trained, what kind of data they pull from, and, crucially, where their blind spots and hallucinations are. A user with high epistemic motivation treats the AI as a complex system that needs to be decoded, rather than some magical black box shortcut that just magically does their work for them.
And we know for a fact this three-part framework works because the data totally backs it up. When researchers tested this critical thinking scale in a naturalistic study using a GPT-powered fact-checking task, the results were incredibly clear. The data showed that higher critical thinking scores directly, positively predicted more frequent verification behaviors. And most importantly, it predicted significantly higher accuracy when judging whether the AI was actually telling the truth. Basically, when users engaged these 3 cognitive dimensions, that whole AI usage illusion just vanished, and their actual performance soared.
Which brings us to Section 5, Designing Explicit Verification. What is the actionable takeaway for product teams and developers building the future of AI?
The biggest takeaway here is that you absolutely cannot just build for AI exposure. If you just give people a shiny text box and hit go, they are going to fall right back into that heuristic slumber. You have to design infrastructure that physically forces them out of it. For example, in the study, they used an experimental interface that didn't just hand the user an answer. Instead, it explicitly required the user to click on source links and then manually choose whether the AI statement was correct, incorrect, or unsure before they could even move on. By intentionally injecting that cognitive friction, the interface actively forces the exact kind of verification behavior we've been talking about.
This leads to a really profound realization from the research team. They noted that the core strength of critical thinking in AI use isn't just about reading the evidence the AI conveniently hands you on a silver platter. It's really about the active closing of evidence gaps. The data shows the absolute best AI users go out of their way to seek out corroboration far beyond the chatbot itself, especially when the AI gets a little vague on its sources. This means our workflows or educational tools in our software must be explicitly engineered to prompt, require, and reward that exact investigative behavior.
So as you design your next workflow, curriculum, or product, I want to leave you with this final thought. We've seen the data. We know the AI usage illusion is real, and that mere access to these tools absolutely does not equal success. The magic doesn't just happen because the AI is turned on. So in your own work, are you merely building for usage, crossing your fingers and hoping for the best? Are you actively engineering for verification? Thanks for joining me on this explainer. Keep questioning, keep verifying, and we'll see you in the next one.